Everyone's doing well. This video I'm going to go through quickly how to find the area using the definite integral between two curves. Okay, and we're going to use a definite integral. So a couple things to think about again. We've been talking a lot about the antiderivative, the indefinite integral. And we're going to move back to the definite integral. So let's suppose I have some function, little f there. Right, and I want to find the area under that function from, say, a to b. Right. Recall that that is the definite integral from a to b of f of x with respect to x. Okay. Now that is that area, right? As noted here, it can be positive, it can be negative, it can be zero, but it's area, right? And it's area because of the definite, the upper bound b and the lower bound a. Right. Giving it limits of integration. Remember, the fundamental theorem of calculus tells us that to get that value, we can take the antiderivative at b minus the antiderivative at a. Right? And so this guy right here, that's the antiderivative of little f, the integrand. Okay? We're going to use our calculator quite a bit to work out this piece right here. Okay? Something to consider would be to find the area bounded between two curves. So how do we find the area between two curves or two functions? Right? And so we'll kind of establish this philosophically, and then we'll look at a specific example. So let's suppose I have some function here, and I'll call that f, the blue, and I'll call this little function down here g. Okay, and what if, say, I wanted to find this area here, and that will give a letter A and that will give a letter B. Okay, so that shaded region is the area between, bounded by, two functions, right? And so to find that area, what I can do is I can first take the definite integral from a to b underneath the top function, right? So the the f, the blue f function, is the higher of the two functions, right? And so as it stands right now, if I were to add my dx right now, then that area would be this shaded area, right? And including this piece in here, right? So far, that's this particular definite integral, right? But what I want to do is from that, I want to subtract the area underneath the red function, right? And so literally all I'm going to do is from that subtract, get rid of that dx for now. So from f I'm going to subtract my g, my lower function, right? And I'm going to now throw in my dx as a placeholder. Okay. So in general, to find the area between two functions, we integrate from a to b. I would call it the upper function minus the lower function with respect to x, right? And what that is doing is when we take the area underneath the upper function, we get that area, and from that we subtract the area underneath the lower function, right? Which results in the area between. Okay, so there's the concept. Let's look at a particular example. And so what I want to do, get this to turn on, and so I want to find a little smidgen of this area. So check out the graph, and this top guy is cosine and this guy right here is y equals x. What I want to do is find this little area right in here, that little piece of pie. Okay, so I'm going to kind of blow it up a little bit. I'll zoom it around, and I'll go from I'll go from 0, let's say, to, I don't know, pi over 2. Or just pi actually would work better, and that gives me a little better view. And now I can stretch out the y frame. Whoops. So the y's need only to go, let's say, from -1 to 1, and now we should be in business. Okay, so what I want to do is, if this is the cosine function and incoming here is the linear function y equals x, I want to find this area right here. Okay, so what that looks like is, if I were to sketch a quick sketch here, here's cosine, All right, starts up here at 0, 1. Here's y equals x. Right. What I want to do is I want to find this area trapped between the two. Okay. So what I want to do is I would first want to find the area, the definite integral, from 0, because I'm starting right here, but I don't know what my upper limit of integration is. So in order to do that, I have to use the second calc intersect option. Right? I know my lower limit of integration is going to be 0, but I don't know where to stop my upper limit of integration. So to get that value, I'm going to use my second calc intersection piece, right? So a second calc, and I want to find where these two guys intersect. I press enter. My first curve is cosine, press enter. Second curve is y equals x, press enter. And my guess, I'm just going to move up a little closer here. There we are. There's a good guess right there. Woo, that's pretty close. I press enter, bada bing, bada boom. So here's my point of intersection, my x value, which is 0.739, we'll call it. Okay, so I'm going to call that 0.739. Now that's one of the things I want you to be thinking about, finding that point of intersection using technology. Okay, so at least now I got my upper limit of integration. Okay, now what I want to do is I want to integrate basically from 0 to 0.739 the area under the cosine function, my upper function, cosine's on top, minus my lower function, right? And when I subtract the area underneath y equals x, I get the resulting area between. Okay, here's my upper one, higher. Here's my lower one. So I'm going to subtract the definite integral from 0 to 0.739 minus, whoops, the area under this triangle, which I can get using geometry too, which will result in this blue shaded area. Okay. So now that I have that set up, there's my setup. Now I'm going to just use my calculator to help me find that value. Okay. So what I'm going to do is I'm going to quit this menu, get back to the main menu, clear all this junk, and I'm going to use my function integrate tool. So I want to integrate basically cosine minus x. Now you could, if you wanted to, use y1 minus y2 in this option, but since it's just as easy to write cosine x minus x, I'll write that. Okay, there's my integrand. That's a function I'm integrating. Right? With respect to x, comma x, and then from comma 0, my lower limit of integration, to comma my upper limit of integration, 0.739. Close up the parentheses, press enter, bada bing, bada boom, 0.400 we'll call that. Okay, and so this calculator technique we went over in class today, remember the function integrate asks us for the integrand, comma, with respect to x, that's a lot like this dx over here. Okay, and then comma, my lower limit of integration, 0, and then comma, my upper limit of integration, 0.739. Okay, so we're using technology to find this particular shaded region. Okay, hope you enjoyed this video. Come with questions tomorrow.